Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about the HashSet class in Java. So by the end of this video, you will understand what HashSet is, its features, and how it works internally, and how to use it with practical examples. So let's get started. So what is HashSet? HashSet is one of the most commonly used implementation class of the set interface. So as we know, the hierarchy iterable is the parent interface and the collection is the child interface. And collection has three more child interface that are list, set, and queue. So these all are interface. Iterable is parent interface, collection is interface, list, set, and queue are interfaces. Now, set has three implementation classes. Implementation classes means the classes which are implementing this set interface. So, first implementation class is HashSet, and another one is linked HashSet and the tree set. So as part of this video, we are learning HashSet implementation class, which is implementing set interface. Okay. So it stores only unique elements. So set has the property of storing unique elements. That is, no duplicate values are allowed. So this property characteristic will be applicable for all three implementation classes. So as part of the HashSet will also store only unique elements, and it does not maintain insertion order. So for HashSet, no ordering and no sorting. What do I mean by ordering and sorting? Ordering means the order in which elements are getting inserted into the HashSet. So those order will not be remembered in the HashSet. That's why I have mentioned no ordering. Okay, no ordering. And sorting means it will not sort in the ascending or descending order. That means it will not provide any sorting. That's why no sorting. So these both features are not available in HashSet. Okay, but HashSet is faster in performance. Why? Means it uses hashing algorithm. Okay, so let's go to some of the points. So HashSet implements the set interface. That's why HashSet is the implementation class of the set interface. It stores only unique elements. It does not maintain insertion order. Neither it sorts the element, and it allows only one null value. So inside HashSet we can store one null value, and it uses hash table internally. Okay. So these are the properties of the HashSet. So it does not preserve insertion order, and it allowing a single null value. Okay, and internally uses hash table for fast operations. Okay. So let's see some of the features of HashSet. So HashSet is part of the Java collection framework. Okay. And it implements the set interface. Okay, and set interface which extends the collection interface. So we know the hierarchy. So as per the hierarchy, we can know the feature of HashSet. So HashSet, unique elements only. It allows unique elements only. Okay, and no insertion order. It allows only one value, not synchronized. Okay, not synchronized means thread unsafe, and faster in performance. We will learn this thing in detail in the topic of multi-threading. What is synchronized, what is thread unsafe, and why it is faster in performance. But for now, I will give you just a brief Synchronized means there will be some inter-thread communication. Let's say we have one resource, okay, resource, and multiple threads are trying to use this resource, okay, use this resource. There is no synchronization. Let's say if one thread is doing some operation in between, another is also using, so there is no thread safety, okay, that we call thread unsafe, not synchronized. If it is synchronized means there will be thread communication. So if one thread is using, and while using this resource, this thread 1 will tell to thread 2, okay, I'm using, I will let you know once my usage is done, then you can start. So thread 2 will say, okay, let me know once it is done. So after usage of T1, thread 2 will start utilizing resource 1. So there will be some thread communication. So we call it as synchronized. Okay. So since there is some thread communication, so we'll call it as thread safe. If it is synchronized, we'll call it as thread safe. And since there is some extra process of communication between the threads, it will be slower in performance. Okay. So this we will see in detail in the topic of multi-threading. Okay. But for now, this brief is okay, I think. So HashSet is not synchronized. So you can think of opposite whatever I explained here. Okay. So not synchronized means thread unsafe, thereby faster in performance. So fast searching, inserting, and deletion. And it can store heterogeneous objects. Okay, HashSet. So it stores only unique values. It does not guarantee any order. Okay, it allows only one null element, is not thread safe, and thereby provides faster in performance and can store different types of objects, okay, if declared as object. So these are the features of HashSet. Now we will see how HashSet works internally. Okay, so here you can see, right, element. So whenever we insert an element, how it works. So first of all, it will generate hash code for this element. Okay, so it will generate hash code using hashing. Okay, so for this element, it will generate one hash code, and for that hash code, it will find the bucket index. So based on the hash code value, it will go to particular bucket. So based on hash code, it will go to particular bucket. And how hash code is generated? With the help of element. Based on the element, hash code will generate, and with the help of this hash code, it will go to the particular bucket, and inside this bucket index, we will be having multiple elements. Okay, so for that multiple elements, it will check equality using equals method. This is like built-in methods provided by Java. So it will utilize these methods to check the equality between the elements presented in the same bucket. And if whatever elements present in the same bucket, if it finds duplicate, it will discard duplicate. That means it will not add the new element which we are trying to insert. And let's say after calculating hash code, it finds out the bucket, and after finding out the bucket, it compares with the another remaining elements inside this bucket using equals check method, and it found out that this new element is unique. That means it is not equal to other remaining elements. In that case, it will store the element in the bucket. So that's how an element is get stored in the HashSet. Okay, so this is like internal working. So I will give you a brief. Whenever an element is added to a HashSet, so Java first calls the hashcode method. Why hashcode method? To determine the bucket location. Okay, and if another element already exists in that bucket, so Java uses the equals method. Why it uses equals method? To check whether it is a duplicate or unique. And if it is found the new element is added, that means no element is same as the new element. In that case, it will add this new element in the bucket. Okay, so that is the whole process, how it follows internally for the hash set. Okay, now let's go to IntelliJ and see some example of hash set. Okay, so we'll get better clarity. So we are learning hash set. So hash set is what? Hash set is the implementation class of the set interface. Okay, so I will create hash set. So in the generics we will provide data type. Okay, so for this example I will provide a string, a set of string. It can be any type. Okay, string, it can be integer, or it can be custom class also. Okay, custom class means we can create our own class like student, like that. Okay, so hash set of string, let's say fruits equals to new hash set. Okay, so we created an object called hash set. So creating a hash set is simple. Okay, we import the hash set. If you can see java.util method. Okay, java.util package, and created an object using generics to specify the type of elements it will store. Okay, now let's say I want to add an element in this hash set. So what I will do, we have the methods, right? Dot add is the method for adding an element. And what type of element I can add? String. Okay, so let's say fruits, apple, and then let's say I will add fruits dot add. Okay, mango, fruits dot add banana. Okay, so I will add 3 to 4 elements of string data type, and let's say I'm adding apple again. So we'll see whether it allows or not, since it is duplicate value. So I am printing fruits. Okay, so we all know, right, fruits I am printing. I am not iterating using for loop for printing each elements present in the hash set. Why? Because fruits, this hash set built-in class, it already exists the toString method, and toString method means toString method will be used for displaying all elements present in the hash set. And whenever we call in the print statement this thing, it calls automatically that toString method. So that's how it internally works for printing the elements present in the hash set. Okay, so since we have added, this is a duplicate element, right? Duplicate element, and we know by property of hash set it does not allow duplicate elements, and we have seen how hash set works internally. Okay, so whenever we are inserting an element, okay, so for this element it will create first of all hashcode method, then it will generate, right here. Okay, so for this apple, second apple I'm explaining. Okay, first apple is added in the hash set. For second apple means this fourth element. Okay, then apple, let's say it will first call hashcode. It will generate the hashcode value, and based on the hashcode it will find the bucket, find the appropriate bucket and bucket index. Okay, and after finding bucket index, it will check using equals method with remaining, okay, with remaining elements present in the same bucket. Okay. So using hash code, it will find the bucket and it will check using equals method whether the existing elements on the same buckets are same or not. So there is two scenarios. If existing, like, it is unique, then what it will do, it will add in the hash code, add in the hash set. And if it found to be duplicate, in that case it will not add. Okay, so that's how internally it is working for each of the element. Whenever we are calling add method internally, how is it working? First, it is generating hash code, and based on the hash code value, it is going to the appropriate bucket and it is calling equals method to compare with the remaining elements in that bucket to check whether it is unique or duplicate. If it found unique, then it will add in the same bucket, and if it found to be duplicate, it will not add in the bucket. So that's how it is processing internally. So for this, so apple, mango and banana will get inserted. Why? Because they are unique, and when we are inserting apple, it will go into bucket by calculating hash code, and after going to bucket, it will found that apple is already there, then it will not add in the hash set. So if we are trying to print fruits, then only apple, banana and mango will get printed. And since we know hash set is what? Hash set follows no ordering and no sorting. Okay, so no ordering means it will not remember the order of insertion. So what is the order of insertion here? First apple, then mango, then banana. This is the order of insertion. But while printing, it will not maintain order. It can print in any order. Okay, so it will not include this last apple since it is already included. So output will be apple, mango and banana. Okay, an order can vary each time when you run. Why? Because hash set does not provide ordering. It does not maintain insertion order, and neither it maintains sorting. So let's verify what we have discussed so far. So in the output, we can see it is apple, mango and banana. It is not adding the second apple, okay? Why? Because it is duplicate element. So here we are adding 4 elements. Since apple is added twice, hash set stores it only once. And if you also notice that the output order is, in this case, same. If I run again, it might give different order. Okay, it is giving same order only, but it can give different order. Why? Because it does not maintain ordering. It does not maintain insertion order. Okay, it is giving same only. So no ordering. Okay, it will not maintain insertion order. So that is one of the important points. And we have some common methods as I used add in this example. So I will show you some different examples, common methods. So we know the hierarchy, like iterable, then collections. So collections have the common methods. So in hash set we can use it. Okay, so add method is used for adding an element. Remove is used for removing an element. Okay, so in the last example, we have seen the add method. Likewise, we can remove an element, and contains to check existence of the element, whether it is available in the particular hash set or not. And size will return the size of the hash set. So while solving the coding problems, will be solving in the later videos the coding problems. So this method will be used mostly to check the size of the particular implementation class, in this case hash set. And is empty will also be used in the coding problems. So what is the usage of isEmpty? IsEmpty will check whether the hash set is empty or not. And clear method is used for removing all elements. Okay, so we will frequently use add, remove, and contains, size, isEmpty, clear while working with HashSet. Okay. So now we will see the difference between HashSet and ArrayList. So from the hierarchy, we know HashSet is the implementation class of the set interface, and ArrayList is the implementation class of the list interface. And list and set interface are the child interfaces of collection interface, and collection interface is the child of the iterable interface. So this is the hierarchy: iterable, then collection, and collection again child interfaces list and set, and list interface have the implementation class ArrayList, and set interface has the implementation class HashSet. Okay, so we are comparing these two implementation class HashSet and ArrayList. So before comparing, we in the mind we should know the hierarchy, how in which place it belongs to, what is the parent interface, in which interface these both implementation classes are implementing. So now let's come to the difference. So since this is a set interface, right, it implements set interface. So what is the property of set interface? We cannot add duplicate values, only unique elements are allowed. Okay, and for HashSet we know HashSet no ordering and no sorting for this implementation class. So for HashSet unique elements, and ArrayList allows duplicate elements. Why? Because list interface allows duplicate elements, and it supports index based operation. Okay, so no ordering, no sorting for HashSet we know. And ArrayList maintains insertion order. Okay, it remembers the order in which elements are getting inserted. And HashSet does not support index based operation, whereas ArrayList supports index based operations. And HashSet is faster in performance. Why? Because it uses hash table for faster performance, and we have seen the internal working of HashSet, how it uses hash code and equals method. Okay, hashing algorithm. So hashing algorithm means what? There is a contract of using hash code and equals method. So first it will use hash code method to find out the bucket, and after finding the bucket it will execute equals method to check whether in the same bucket remaining elements are equal or not. Okay, if it found duplicate, it will not add in the hash set, and if the new element which we are trying to add is unique, then the new element will get inserted. And same goes for, like I explained, for adding of an element, same process goes for searching. So since it uses hashing algorithm, it is faster in performance, faster in searching. Okay, and ArrayList is slower search. Okay, so if you need unique elements, okay, so how we will choose, how we will make the decision when to use HashSet, when to use ArrayList. So if we are knowing the properties of HashSet and ArrayList, and we are knowing what is our requirement, so based on these parameters we can take decisions. Okay, so if we want unique elements with faster in performance, then which implementation class will choose? So HashSet will be better choice for unique elements and faster in performance. And let's say you want to choose where insertion order is maintained and accessing of elements using index is faster. In that case, we will go for ArrayList. So based on our requirement, we will choose the appropriate implementation classes. Okay. So when to use HashSet? So we will use HashSet when we want unique values, faster in searching, membership checking. We want to store unique IDs, unique username. It can be unique email addresses, and faster in performance, no ordering, no sorting. So all these parameters we require, then we will go for a set. So these are the key points we need to remember while working with HashSet. Okay, so let's quickly summarize what we have learned so far. So HashSet implements set interface. Duplicate elements are not allowed since it is implementing set interface, and set interface has the property of not allowing duplicate. It does not maintain any insertion order, so no ordering, no sorting for HashSet, and it allows only one null value. So in HashSet we can insert one null values, and it uses hash table internally, thereby faster in performance, and it has time complexity of O of 1. So I hope you got the clarity when to choose HashSet, keeping in mind these parameters. So that's all for this video. I hope this tutorial helped you understand the concept of HashSet in Java. Thanks for watching, and I will see you in the next video.